things and making sure we know what our confidence intervals are and so forth. But where we've been able to look at other cues around vulnerability, around user agent stats on different sites, we've seen that they very closely mirror the numbers that we're seeing here. So we think it's a pretty reliable indicator.
Okay, so we need to keep moving here. So
yeah.
we're going to start talking about
you need to listen very quickly now.
What's coming up in new versions here?
Absolutely. So obviously we do more than just fix these bugs in security updates. And one of the things we try to do with each of our product releases is think hard about what are users doing with the product that is related to their security. And some of these are obvious, right? They clicked a URL, they didn't want to get owned. They entered a password somewhere, they wanted to know if it was the right kind of site. But there are other important user tasks. One of the ones we've just spoken about is getting people to update their friggin' browser. We've got a great record on that. We're happy about it, but 6 days is short, but it's 6 days longer than we'd like it to be. So look at those user tasks and think about how we can make them better. And sometimes we find, in some cases in retrospect, some nice things that we can do to the product that improve some of these user tasks. So things that would be obvious around applying an update would be more bandwidth to the mirrors, more frequent checks done by the browser. We did work many versions ago to ship very small binary deltas instead of whole files or whole packages. So you download 300K instead of 7 megabytes. We also thought about, why do users decline updates? We know that, we're seeing we observed it in user behavior, and we saw stats that made us believe it was widespread, that users were being notified of the update but not choosing to apply it right away. And that's very frustrating. We've got something that will help you. Please let us help you. And the big two reasons that people were afraid to do it, one is that it's too intrusive, right? Your browser's going to shut down and restart. You're going to lose the work you're working on. So I'll do this after I finish this blog post or after I finish reading Penny Arcade. And then you forget, you've declined it, and you leave your browser running for a long time. So it's 2 or 3 more days until you might get notified again or restart your browser for some reason. And in many cases, they're worried about things breaking. The software industry has a horrible record of patches breaking inadvertent stuff. This is an area, again, where our huge tester base and shipping these updates out in small pieces where it's easier to analyze the interactions has been really helpful. So for us, Succession Restore, which is a very popular feature of Firefox 2, when you restart your browser, it comes back where it was for us a security feature. It's something that made it less painful for users to apply updates, and we believe is one of the reasons that we saw that 25% decrease in time to deploy. And API stability is a security feature. Don't break my crap because you made me more secure. Don't make me choose between taking something that will protect me and getting my job done, where you can avoid that. And that's, again, an area where doing these in small pieces means that you're not going to have the whole of the web break when you take a large update. So there's a whole bunch of stuff we're doing in Firefox 3 around improving security of users, both security in the integrity of the code sense, but also security in their behaviors. My colleague Jonathan Nightingale has an hour-long presentation about some of these pieces, which is excellent, so you should mug him for those slides. But we'll give you an overview of some of this stuff here. We did this in Firefox 2, and we're working to make it better all the time. We suspect this is a web forgery. We tell the user that. One of the important things here is that it's in the user's face. They went to this site because they're interested in the content. We know through painful and depressing user studies that users don't look at the Chrome. They're there to browse the web page. They're going to look at the web page. It's got the eBay logo on it. They're going to type their eBay password and get on to what they were trying to do. So it's very important we build these notifications that they're in the way that they can't be ignored, that they can't be missed in this distracted sense. Now you can still click through it, which is the case of many security warnings about bad certificates or possible mismatches, and we're reducing that set of things.
But it also looks different than other security, other dialogues. It doesn't look like any of the other dialogues. It's something completely different. So it takes the user out of the context in which they've been trained to click OK through the certificate warnings or through other dialogues that come up. And
this is, again, an area where making sure that users that you present these things where you're sure means that users don't get numb to them as quickly. So in Firefox 3, we're adding support for keeping a different kind of list of bad sites or heuristics that will be suspected attack site that's trying to install a Trojan on you in various kinds of ways that it's been known to be shipping things to you that you really don't want on your system. And one of the things that you'll notice about this is we were pretty aggressive here. There's no click through on this. This is, you're not going to go here. Which is not going to be without controversy, certainly, and we believe strongly in user choice. But in order to protect our users better, we're going to have to be brave, as Jonathan says, about doing things that are going to see complaints, but we believe are also going to have very strong effects in protecting users better on the web. One important note here, maybe hard to read on the slide. This is a mock-up. Mock-ups change, so don't over-report that. You shouldn't start building your Firefox 3 reviewer's guide on the screenshots and mock-ups I'm going to show you here.
Yeah, until the product is shipped, there's nothing that's set in stone.
Now, if you're interested in these kinds of things, there's certainly one of the benefits of the open bug system is you can follow along with our work there, and you can tell us where we're screwing it up. So please do. Okay, so I'm going to go very quickly now, so we've got time to show off Jesse's awesome stuff. One of the things we also try to do is take advantage of our large user base, not in the take advantage sense that's most common in Vegas, but to derive maximal advantage from the fact we've got 100 million users. They all care enough about the web to download their own browser, and they may notice that this is a phishing site and help report that back to us, that we can give that to the people who maintain those databases and gradually improve the quality of that. We do the same thing with crash reporting. Many crashes are security related or can have a security impact. So as we're doing things with testing, we get crash reports back in. We get an aggregate of these things to help us look where do people need to update their plugins better? Where do we need to mitigate against a problem in a plugin? Where are we seeing uptake of content that's causing these things to be more common? So please submit your crashes. They help us a lot. Very quickly about EV certificates for reasons of time and personal preference. SSL certificates are intended to verify the identity of the site. Turns out that if you don't verify very well, you can ship certificates more cheaply, and there was really no reason not to, so that kind of sucked for a while. EV certs are more thoroughly validated now. Someone goes on site and so forth, so you have a higher confidence in site identity. So one of the things we're introducing in Firefox 3 is the notion of Larry, the international symbol for passport control, which of course is a wonderful identity document. Larry's there. It'll show you the site identity. In this case, we've got SSL and we got a high validation certificate, I believe. So it shows Larry's confident that this is really who it is. One of the important things, though, is that Larry will always be there. One of the problems with the padlock is that it only tells you you're safe. And when you're safe, you don't need to know you're safe. You need to know when you're not safe. So in this case, Larry's always going to be available to tell you about that site. So even in the normal case, you won't have to detect the absence of something. You'll know that and we believe the Mozilla.org site to be a pretty reasonable place to visit. Don't get me wrong, but we can't prove to you that that's where you really are. So you need to be careful. And again, please don't over-report this, or Jonathan won't let me use his slides anymore. There's a lot of information about web security. It's hard to express to users, so we've done some work to improve that over time. In Firefox 3, we'll see some uptake of this as well. One of the important pieces here that's quite interesting to me is, have I been to this site before? If you're trying to figure out whether you should be trusting this site and so forth, that's a good indicator that it's probably the site you think it is. Is it storing cookies? Have I saved any passwords for this site and so forth? There are certainly other things we want to show in this environment, and we're interested in hearing from people's experiences or even just strongly held beliefs about stuff that would be valuable here and understandable, again, to our 100 million users and growing. The users themselves are not growing, but the base is. Under the hood, we've done a ton of work on core technology. We'll skim through some of this stuff here. One of the most important pieces, we rewrote a huge chunk of how we lay out our code, how we lay out web pages, rather. And one of the big reasons was to improve the resilience in error handling cases, in low memory conditions, in the kinds of stuff no one should ever do to a page, but probably will if they're trying to break your browser. Thank you, Jesse. To be much more resilient. This is an example of an architectural change that we're doing in parallel with spot fixes for bugs that we find, to reduce the aggregate and the broad swath of these bugs and the whole class of bugs in that update. And there are a bunch of these things that this could have been a whole talk on its own, but important is we're looking at these as we're looking to review these kinds of code. We're not just looking, are there new vulnerabilities in the code? We're also looking, is there an opportunity as we change these things to improve the aggregate security of the system? In a deeper future, not 2007, probably not 2008, but work we're actively undertaking right now, project we're calling Mozilla 2. One of the big advances is a JITting JavaScript virtual machine that we're working on with Adobe. They donated, was part of the Flash player, is now both part of Flash and a future version, just a future version of Firefox. One of the real great things about this is going to let us move more code from traditionally fragile C++ into a managed environment where we don't have to worry about memory management, where we don't have to worry about certain kinds of pointer manipulation or mismanipulation, string management, and so forth, reducing also the sheer amount of code people need to write. The fewer keystrokes they have to enter, the less chance there is that one of those keystrokes is subtly incorrect. And we've found in a lot of cases that where we're able to rewrite code from C++ to JavaScript in the product, where we see a reduction in bug rate in those things. We've done this with the password manager in Firefox 2, and this will give us a way to do this at a larger scale in the application. This is also an area where we've built some custom static analysis tools on an open source project called Oink to help us when we've identified a construct that we believe to be problematic now, to help us do that historical analysis over the aggregate of the code in there to let us know which pieces need special attention, how widespread the problem is, do we need to write a tool to fix it, or do we need to defend it at a lower layer, or are there only 5 cases and we can just go in and fix them. And these tools are also things we'll be adding to the pre-check-in validation to make sure that we don't regress in these cases. Even today, there are certain cases, misuse of Boolean variables, that will get developers emailed now if they check in something that introduces one of these patterns. So, what you really came here for, talk about some of our tools and the project we're announcing now, and I'll let Window tell you a little bit about some of the stuff we're doing here.
Okay. So, the reason we're making these tools available is because we think they were valuable in our environment. They might be valuable in your environment. But we want to make sure that as we release these, that we're doing it in a way that is as safe as can be for all the other applications that could potentially be impacted by this. So we engaged the other big browser vendors. To make sure that they had a chance to look at these tools, evaluate them, and let us know if they had any concerns. And I did get positive confirmation from all these vendors that they did not have a problem with us releasing the tool that we're releasing today. So I want to make it's a real pain in the butt when someone releases information about a vulnerability without giving us enough time to fix it. So we wanted to make sure that we weren't doing that to anyone else.
And we're very grateful for their cooperation as well. Certainly, there was a past world of browser competition where people would have just said, no, we're not going to let you do anything you want to do because it'll be bad for us. But certainly the people that we've contacted in these organizations share the same goal we do of making the web safer. And so we're grateful that they're working with us on helping us release these tools now and in the future.
Absolutely. So the ones that we're going to be talking about today, and actually since We've got 2 protocol fuzzers that are actually coming out in a couple of months, and since for time constraints, I'm actually going to head and skip to the JavaScript fuzzer, which is what's available right now, and turn it over to Jesse so he's got an opportunity to talk about this.
So I started writing this fuzzer about 11 months ago. It creates random JavaScript function bodies and asks the JavaScript engine in Firefox to compile them, run them, and decompile them. It does this by the function make statement knows that one way to make a statement is to have var and then a variable name and then equal sign, expression, and then semicolon. And then it knows to make the expression part of that. Make Explorer knows how to make a bunch of different types of expressions. But then also it'll violate all these rules it knows. So sometimes where the var statement calls for a variable name, it'll stick in a pound symbol or a try keyword or whole expression. And that helps it hit syntax error handling code in the JavaScript engine. It's found a lot of bugs, including 24 exploitable bugs, and I think it's able to do this because it knows a lot about the JavaScript language, but it breaks the rules it knows. It's not scared to make deeply nested statements, put things in loops, and it can also accumulate state as it runs lots of different functions. And it's also testing for certain aspects of correctness, so it's not just finding crashes. And here are 3 examples of exploitable bugs it found.